So what is this cross product? Okay, now we know that the product of this operation must yield this value, vector quantity. So this must be the output. Now, let's say you have here a vector moving in this direction and then another vector, okay, another vector that is moving in this direction. Let's say this is our vector A, and let's say this is our vector, let's say this is our vector B. Now, if we want to find the cross product of vector A cross vector B, remember that the cross product of this one is not equal to the cross product of this one because the direction will affect, and thus the left and the right is not the same. Okay, well, anyway, we have to find the cross product of A cross B. How do we get this? Well, the easiest way for us to do this one is use the matrix formation. We have to get the components of A and then components of B, and then we will going to get like this I, J, K. So the I hat of A as I, J of the J of A, and then the K component of A, the B I, the I component of B, the J component of B, and the K component of B, and use determinants, find the determinants. So we will get, we have to first do this one, multiply this, subtract by, so let me just write it down for you. So we have here AJ times BK minus AK times BJ minus the next one. Let me just delete that highlight. So the second one is J, to get rid of that one. So J, same, multiply this by that and this by that. Okay, what we get is AJ BK minus AK BI. Okay, plus next is J or K, so we have to do this one, same process, multiply this by this and subtract by the product of this one. So this will become K times AI times BJ minus AJ BI. And this is actually already the answer. So the cross product of A and B is this one. This will be the equation that we were going to use in solving for the cross product of vector A and vector B. Now we could use the right hand rule, okay, by using this one. Our pointer finger points to the direction of A, our middle finger points to the direction of B. This is pointer finger, this is our middle finger, and the thumb points, this is a thumb points to the direction of the cross product of A and B. So it means that if we have this vector A and B, therefore the direction of the cross product must be above along Z, okay, using the right hand rule. And the components or the value of this is equal to this equation. Okay, so this is how we solve or get the cross product of a vector. Let me give you an example. The components of vector A is 2x plus 3y, while the components of vector B is negative 3x plus 5y. Okay, and then find the cross product of vector A and vector B. So what we can do is put this one in a table. So we will going to create a table. It would look like this one. Okay, so we have here for x, y, and z. Now the first one is A, so we will going to get the coefficient of every term. Let's say for x, the coefficient here is 2, place that one here. The coefficient of y is 3, and since we don't have any z, so this becomes 0. For B, same, the x component or the x term get the coefficient that is negative 3. For the y, that's positive 5, and then there's no z, so it's 0. So the same process, let's start with x. For x, we have to multiply this by this, multiply 3 by 0, and then subtract 5 times 0. So that is 3 times 0 is 0, 5 times 0 is also 0. So we don't have any x component. It's end up to 0. For our y component, that's negative. So the same process, just delete. Omit this, we're left with this value 2, 0. 2 times 0 is 0, minus negative 3 times 0 is also 0. So we have 0 minus 0 is also 0. Let's proceed to the z. For the z, I'm going to get rid of this one and this one. So we have this and this. So 2 times 5 is 10 minus 3. Negative 3 times 3 is negative 9. Okay, so we have here 0 0, so we have z 10 plus 9, and we end up with 19z, and this is our cross product. So this means that this is along the direction of z component with a magnitude of 19, right? So this is the basic uh, operations you could find in cross product. By the way, you might notice or wonder why there is a negative here. So actually it should be an alternating, so positive, negative, positive, negative. This is for x, this is for y, this is for z, and so on and so forth.